Hi everyone, in this lecture we will see the operation of class D chopper. A class D chopper is a two-quadrant chopper which can operate in first and fourth quadrant of output voltage and current plane. So in this chopper, the power can either flow from source to the load or load to the source depending upon the quadrant of operation. Now let us see the circuit diagram and working of a class D chopper. In the first quadrant, the output voltage and the current of the chopper must be positive, whereas in the fourth quadrant operation, the output voltage should be negative and current is positive. So if you look at the circuit consists of two switches. Here I have denoted as chopper 1 and chopper 2, and you have two diodes D1 and D2. These are all generally a power semi-conductor device and which can be either a transistor or a thyristor based switches, whose switching is basically controlled by controlling their gate pulses. Now let us see the working of class D chopper in the first and fourth quadrant separately. In the first quadrant operation, the switch S1 and S2 is on and the load starts receiving the power, that is the RLE load, which starts receiving the power from the DC source. Now the current starts flows in the DC in the circuit is VDC, chopper 1, then load, chopper 2 and back to the VDC as indicated in the red color arrow line. During this interval, the switch S1, that is a chopper 1 and chopper 2 is on. The output voltage V0 is positive, will be equal to the source voltage. So the output voltage V0 is equal to VDC. And if you look at the output current, this output current increases exponentially because the inductance in the load stores the energy during this period. So the diode D1 and D2 will be remain in the off state since they are reverse biased. So now we can see the output current I0 and the output voltage V0 remains positive during the whole period, and hence the first quadrant operation is obtained. Now if you look at the fourth quadrant operation, in the fourth quadrant operation the switch S1, that is chopper 1 and chopper 2 are off and the load is totally disconnected from the source and the load current stops flows in the circuit. But at the same time, if you look at this inductive load, the inductive nature of the load does not permit a sudden drop in the load current. So what happens is, so the huge amount of voltage is induced in the inductor in the reverse direction. So if you look at the polarity of the inductor gets reversed and the inductor starts discharging in the reverse direction. So this causes the diode D1 and D2 in the forward bias. So the energy stored in the inductor is getting released gradually through the load, then D2, then come to VDC, then D1 and back to the load as shown in the red color arrow line like this. Now we can see that the direction of the output current I0 has not changed, but the polarity of the output voltage V0 is getting reversed because the inductor is getting discharged. So the output current remains positive whereas the output voltage will be negative. So hence the fourth quadrant operation of the chopper is obtained in this case. So therefore you can see that when the switches are made to conduct, the chopper operates in the first quadrant. As you see in the first circuit diagram, the switch S1 or chopper 1 and chopper 2 is on. This chopper will be in the first quadrant of operation. The current flows from source to the load. Whereas the switches are off, that is a chopper 1 and chopper 2 are off, this will be working in the fourth quadrant of operation. The current flows from a load to the source. This is the output waveform of class D chopper. You could see two cases. One is turn on period of switches more than the turn off period. The other case is turn off period of switches is more than the turn on period. So we can see the second one. During the turn on period of chopper 1 and chopper 2, the output voltage become positive. So if you see the blue color line, the output voltage is positive. And if you look at the output current is gradually increases to the maximum value due to the presence of the inductance. Whereas during the turn off period, the output voltage V0 is become negative and the output current will gradually decreases due to the discharge of the inductor. So during the turn off period of the switch, the source current, that is IDC, will become negative. So which represents the current is flowing from load to the source. Similarly, the waveform when the turn on period of switch is more than the turn off period are shown in the left side. So if you look at the average value of output voltage, this is the equation VDC T on minus T of time divided by the total time period. So where we can see that the output voltage will depends on the turn on and turn off period of the chopper. So when the turn off period is greater than the turn on period, if the duty cycle is less than 0.5, So if you look at the average output voltage will be negative. So when the T on time is greater than the T of time, then the duty cycle is greater than 0.5. So the average output voltage V0 become positive. So when the T on time is equal to T of time, if the duty cycle is equal to 0, then if you see the average output voltage, it is 0. So therefore the average output voltage of the class D chopper can be either positive or negative depending on the duty cycle. But the average output current of the class D chopper will be remains positive irrespective of the duty cycle. Thank you for watching.